Hello, my name is Alex, and in this video we're going to be going over the Docker Compose file, and more specifically we're going to be learning how we can set up multiple containers to work together to achieve a specific goal. So for example, you may want to set up a web application with an attached database, and you want to do that within Docker as two separate containers that work together, and the easiest way to do that would be to use a Docker Compose file to essentially instruct Docker how to start those containers, what to attach to those containers, etc. So having that said, let's quickly take a look at the architecture that we're going to be following. Now, if you remember, in the previous video, we've discussed the general Docker architecture, where we had a Docker client, which can be any client on your machine. So basically, this can be a GUI, a command line tool, or anything else. Then you have the Docker host, which is your machine or any machine running the Docker daemon process. And then you could use the Docker daemon to essentially generate images, start containers, attach volumes, etc. So basically, Docker usually runs on a single machine, and then you can use the Docker daemon process running on that machine to perform various actions. Now, obviously, you could have several machines running Docker using something known as a Docker swarm, but this is outside of the scope of this video. So basically, we're starting with the idea that we have a single host, and then we want to start up several containers on this host, with these containers being able to communicate and rely on each other. So basically, we arrive at this architecture up here, where we have the Docker Compose file, which can be used by essentially using a Docker client. So you can use any Docker client to interface with your Docker Compose file, and then you should be able to run various commands on your Docker Compose files to essentially orchestrate the setup and running of those containers. So let's start from the very beginning. Now, in the previous video, we've explored how we can use Docker files to build images, and then those images would essentially be used to run containers. Now, in this case, again, we have a file, which in this case is called a Docker Compose file, and the file in question can be used to run several containers at once and allow those containers to work together to achieve a specific purpose. So let's imagine that you want to run a web application. So let's say we have an Angular application, which should rely on some sort of database, and at the same time, there should be some sort of web server, which is used as a reverse proxy. Now, if you don't know what that is fine, but let's just say we need a web server, we need a web application, and then we need a database. So to make these three to actually work together within Docker, within a Docker environment, we need some sort of way to interconnect them. And at the same time, we need to ensure that we can run these containers together, and we need to also set the order in which those containers should run. Now, to do all of that, we can essentially create a configuration via the Docker Compose file. Then we can leverage the Docker Compose file by using specific commands to essentially start up our containers and then manage them in various ways. Now, within the context of a Docker Compose file, we're essentially defining what are known as services in order to configure our containers. So each individual container will be encapsulated within a service, and the service itself will dictate how that container will run, how that container will be interfacing with other containers or other services, and generally how that container will be configured within the scope of our Docker Compose file. So essentially, to recap, we have a Docker Compose file in which we define services, and these services allow us to run various containers. So let's go ahead and take a look at an actual Docker Compose file. And in here, I have created a file called docker-compose.yml, and this is the naming convention for the Docker Compose file. So this is a YAML file, and when we're going to be running our commands later on, the commands should be run from a directory with this file present. So basically, you're not specifying the path to the actual file within the command, although you can do that. All you need to do is to run the command from within a directory with that file present. Now I'm going to be actually showing you an actual demo of two containers running off of a Docker Compose file. But for now, let's go into this demo folder, and I'm going to show you an example of a Docker Compose file that we're not going to be running, but it will essentially encapsulate everything you need to know to begin working with your Docker Compose files. So let's jump into the file itself, and as you can see, this is a pretty small file with most of the stuff that you're seeing being simply comments. And let's go ahead and start from the very beginning. Now, in older versions of Docker Compose, you could actually define the version of your Docker Compose file up top. So basically, you would just say something like version and then specify the version of your Docker Compose file. That would essentially dictate the format of your file and what you could and could not use within that file. However, this has been deprecated. So if we go on the official Docker website, if we actually go back here, if we go to the specifications for using a Docker Compose file, and more specifically if we go to versioning, you will see that since Docker Compose version 2, we're not using the version anymore. So basically, you can switch to the new specifications if you want to learn about Docker Compose in detail, but generally just know that versioning is not used anymore in Compose version 2. So essentially, this means that you no longer need to specify a version up top, but if you see a Docker Compose with a version, just know that this is a legacy file. So essentially, since version 2, even if you're using the version property, it will be ignored. Now, moving on, here we have our services. Now, the services here define our containers. So essentially here, we define the name of the service with a column, and then in here, we define the configuration for the service. Now, in this case, we're saying that our service will be based on a base image. So in this case, this is the Nginx latest image, and it will be fetched from the default Docker Hub repository. So essentially, we're fetching a pre-made image here, and we're using that image to start a container. Furthermore, we're mapping the port 80, so our external port 80, to the internal port 80 of our image. So basically, once this container starts, we're assuming that by default the Nginx server will be run on port 80, and then we want to map the internal port 80 to the external port 80 on our host machine so that we can actually access this container. Now, with that said, we're also attaching a volume. Now, volumes can be used to attach a local directory or file on your local machine to a directory or file on your container. So with Nginx, so with a default Nginx image, when you start up a container, you will have a directory named etc/nginx/conf.d/default.conf. So essentially, you have this file located within this directory of your Nginx container. So basically, following that logic, we want to replace this file with our own file, which is nginx.conf. So in this example, we would need to actually have this file present here, so we could go ahead and we could create this file. And then we would be able to use this file to provide configuration for our Nginx server. So effectively, our local file would then replace the configuration of our Nginx server. And this would effectively allow us to change the configuration of our Nginx server by manipulating this file. So basically here we can also attach other volumes, and we can even attach specific directories as volumes. And basically this would allow us to attach directories from our local machine to our running container. Now moving on, we can also define a property called depends on. And this is done by saying dash, then space, and then the name of a different service. Now, this essentially allows us to define an order in which those services will be run. Now, if our web service depends on the application service, this essentially implies that the Docker Compose will try to start the application service before starting the web service. Now, this does not mean that it will wait for the application service to start up completely. It will just start the application service before starting the web service. There is no guarantee that everything that needs to be loaded on the application service will be loaded before the web service. To do that, you would need to implement additional logic which ensures that your application service has fully started before your web service. But in general, depends on allows you to essentially define the order in which your services will start. Now, lastly, you have networks, and networks allow you to essentially connect containers together and allow them to communicate. So basically, you could define a network, and we will look at how you can define a network in just a second. But basically, you can define a network or multiple networks, and then you can place services or containers on those networks. This will effectively allow them to communicate within said networks. Now, having that said, let's move on to our application service. And in this case, the difference is that instead of using an actual image, we're saying that we're going to be building an image from a specific directory. So this assumes that we have a directory called app, and basically in here I have placed an Angular application alongside with a Docker file from our previous video, and effectively what this does is it looks for a Docker file within this directory, and then it will build an image from that Docker file, and then it will use that image to start a container. So here you're using a build command to essentially build an image and run a container instead of importing a pre-existing image. Now, the next section is the environment section. Now, the environment section allows you to define what are known as environmental variables. Now, environmental variables can be accessed from within the application in question. So let's say this is a Node.js application, and then whatever you put inside of said environmental variable can be accessed from within the application. This is very useful for things like connection strings, etc., which should not be defined within the application itself, but should be defined within the configuration of your container. So in this case, you could say something like process.env.database URL from within your Node.js application, and that would fetch your environmental variable. So essentially for different frameworks, this will be different, but you can fetch your environmental variables as long as they're set within the context of this container from within your actual applications. So basically, in this scenario, you can provide any environmental variables to your application. Just be aware that they will be available from within your application globally. So basically, inside of your application, you would be able to fetch the specific environmental variable from pretty much anywhere. Now, having that said, let's move on to volumes, and volumes are essentially, just like we've mentioned before, a way for you to mount a specific directory or file on your local machine to a directory or file within the container. So just like before, instead of actually mounting a file, what we're doing is essentially we're saying that we want to uh, actually mount the application folder, the entirety of the application folder, to the /code folder within the container. So basically, that would simply take this folder and it would essentially mount the content of this folder to the /code folder within the container itself. And again, our service here, the application service, depends on the database service down here. And this means that the order in which these services will be started will be starting from the database service, then the application service, and then the web service. And again, this is because the database service, as we will see later, does not depend on anything, while the application service depends on the database service, and the web service depends on the application service. So basically, in this way, you can define the order in which your services will be started. And all of our services, as you can see here, are on the webnet. So basically, all three of our services share the same network. And this means that they will be able to communicate with each other as long as the network configuration allows for it. And lastly, we have the command property right here, and it essentially overrides the default command for the container. So for example, you could have a command like this, which essentially says Flask run, and then you could override that command by providing your own command like python app.py. So basically this is just an optional way for you to define custom commands, which will override the default command within your image. Now, having that said, let's move to the last service, which is the database service. And again, this service essentially inherits the Postgres latest image. So we're providing a pre-made image, and in here we can set our environmental variables. So we can set something like a Postgres database, the username and the password. And then in here, we're essentially using a specific volume, and we are attaching the data within our Postgres database to this volume. So in this case, we want to make the data in our database persistent. And since we know that the data in our database is stored within the data folder, we can attach the data from here, from this folder within the container to the actual to our actual volume here. So we have a db data volume, which we define down here, and we will take a look at this in a second. But we're saying that the content of this directory within the container should be mirrored by our db data volume. So basically this is just a way to make our database persistent. And again here we're simply defining a network, which is our webnet, and this concludes our three services. And now, having that said, let's move to the last two sections which we're going to be covering in this video, which are the volumes and network sections. Now, the volume section is used to create new volumes, so it is as simple as that. So basically within this section you can define any number of volumes and then use these volumes in a manner like we saw before to attach them to specific containers. Now, when it comes to actually defining a volume, all you need to do is to essentially provide the name of the volume followed by a column. This will effectively create a new volume with a default configuration for you. Now, the default configuration for a volume would essentially create a volume designed for your local file system. So usually you would leave it at that, but in specific cases, you would need to create volumes for specific environments. These could be cloud environments, multi-host environments, or any other sort of environment which would require a different type of volume. So the idea is that if you want to specify a custom configuration for your volume, you could follow this convention. So under the name of the volume, you would specify the driver, and that would be custom to the environment that you're creating your volume for. So again, in this case, this configuration would essentially create a volume for our local file system, but in specific scenarios, just like I mentioned before, this configuration would be different and it would heavily depend on the environment that you're creating your volume for, and this is pretty much outside of the scope of this video. Just know that you can provide your volume configuration like this after stating the name of the volume. But again, normally all you need to do is simply state the name of the volume with a column without providing any additional configuration, and that would create a volume with the default configuration for you. Now, when it comes to networks, the principle here is very similar to what we had with volumes. So you can create a new network by simply stating the network name, followed by a column, and then underneath you can state your custom configuration for your network by simply stating the corresponding properties underneath the network name. So in this case, I'm stating that I want to use the bridge driver to override the default driver. Now, the bridge driver in this case allows communication between containers running on the same host. Now, again, a host or a Docker host is essentially a machine on which the Docker daemon process runs. So normally, all of your containers will be running on the same host, and using the bridge driver will allow those containers to communicate as long as they are on this network. So basically, the idea here is that you're defining a network and all of the containers within that network will be sharing this property. So besides the bridge driver, you also have the host driver, and this will allow all of the containers which are on this network to directly communicate with the host machine. So basically, this removes the isolation between hosts and networks. Now, you can also state that the driver is none, which will effectively disable networking for those containers on that specific network. Now, the last driver I want to mention is the overlay driver, and the overlay driver is a little bit special. Now, when using technologies like Docker Swarm, which allows you to orchestrate the functioning of containers on different machines, so basically let's imagine that we have different Docker hosts, so different machines running Docker. In that case, we may want to essentially manage the way that these hosts operate, and we refer to these hosts as nodes. And then we want to also manage how we want the containers on those hosts to operate as well. So basically, Docker Swarm allows us to orchestrate the operation of separate Docker hosts in a very controlled way. Now, on that note, we may want containers on different machines, aka on different Docker hosts, to communicate with each other. To do that, we can create something known as an overlay network, which sits on top and allows those containers on different hosts to communicate with each other. So basically, by setting the driver to overlay, we are creating a network which allows communication between containers which are sitting on different Docker hosts. Now, obviously, besides the driver, you have many other configuration properties which we're not going to be discussing in this video, but basically you can tailor any network to suit your needs. Now, having that said, let's go ahead and let's quickly recap what we just saw. So to begin with, we looked at services and we've looked at service configuration. So these are the most essential properties that you need to be aware of to set up your own services. You will always be using either an image or a build to essentially tell your Docker Compose file from where you want to start building your container. So basically, a service will always encapsulate a container, and then from then on, you can provide custom configuration to that container. So you can define the ports, the volumes, the networks, and you can even dictate the order in which these containers should be run. So generally, when talking about services, we are talking about container configuration. So always keep that in mind. Now, beyond the services, we've also looked at our volumes, which allow for persistence of data, and then we've looked at our networks, which essentially allow us to customize the way in which our containers communicate. Now, for the next part of this video, we're going to be creating a very basic Docker Compose file by following a tutorial on the official Docker website. And the goal of the application that we're going to be setting up is to simply create a web application which is going to count how many times a user has visited that application. Now, if we go into our primary folder here, in here we have a Docker Compose file and we also have an application folder. Now, inside of our application folder, we have our Python application, we have a Docker file, and we have a requirements file. So let's go ahead and let's take a look at the Docker Compose file first. So basically, let's go into our code, and in this case, we will need two services. So essentially, we want to set up two containers. The first service is our web application, and in here we have to provide the path to our application folder containing our Docker file. So basically, in here we just want to say /app like this. And essentially, this will build an image based on this Docker file right here. Furthermore, it's going to map the port 8000 to the internal port 5000 of our application. Now, if we go into our Docker file here, you will see that we're stating that we want to expose port 5000 here. Now, this is done more for documentation purposes since we're explicitly exposing the port in here. So basically, this is just a way of stating that this is going to be the port that we're going to be using, but this command does not actually expose the port. Rather, the mapping here is used to map port 8000 on your machine to port 5000 inside of your container. So basically, by default, when you run Flask, it will run on port 5000, so you don't really need to explicitly state that you're running Flask on port 5000. So basically, we're using the default port here, and we're mapping the default port here to port 8000 on our machine. So basically, this is a pretty standard configuration. So our Docker file here uses a Python Alpine image. We are creating a work directory called code. We're creating two environmental variables called Flask app and Flask run host. And then we're using the requirements.txt file to effectively install the Flask and Redis dependencies. So basically here we're stating our list of dependencies, and then we're using pip install here to install all of those dependencies. So then again, we're stating that we're going to expose port 5000 at some point, and then we're copying all of the local data into our container, and we're running Flask. Now on the side of the application, as you can see here, we're not explicitly running the application from inside this file. We're defining our routes here, but we're not running the application from inside this file. Again, rather, we're using the command property here to essentially run the Flask application. So let's actually try and recap what happens here. We begin with our docker compose.yaml file, which is essentially used to build our two services. Now, when building the web service, the docker compose.yaml file will go into the app directory and look for the Docker file. In turn, the Docker file is going to run the Flask run command to try to run our app.py Python application. Now, it detects the file in question by looking up the Flask app and Flask run host environmental variables automatically. So the Flask run command will look up these two variables automatically, and then using these variables, it will be able to detect that we want to run the app.py script, and the host in question is used to expose our Flask application to the outside as well. So this is why we're setting the run host to 0.0.0.0. So basically, after the Flask application runs, we enter the app.py file, and in here, as you can see, inside of this file, we're importing Redis and we're importing Flask. Now we're using a Flask application and we have the default route here, and when this route is accessed, we trigger the hello function, which then triggers the getHitCount function and outputs the number of times that the page has been visited. Now up here we have a cache which is essentially initialized as a Redis cache which runs on a different port, and then in here we have a number of max retries, we have a while true function, and essentially it attempts to increment the number of hits inside of our Redis cache, and then as long as the retries have not been depleted, it will try doing that in case there has been an error. So every single time we're visiting this page, ideally the cache should be incremented. So essentially, again, this is a very simple application which increments the number of times the page has been visited using Redis. So again, we're only using two containers here, our web application and a caching mechanism. Now with that said, let's go ahead and let's try to run our Docker Compose file here to actually set up our application. Now to do that, we're actually gonna go into our previous demo file, and down here I have specified the commands that we're gonna be looking at. And the first command that we want to look at is the docker compose app command, which essentially starts all of the services. Now, the app command is only used to start a service for the first time. So it will automatically build all of your images, it will automatically create your network, set up your volumes, etc. So basically anything you state in your Docker Compose file will be initialized using the docker app command. Now, similarly, the docker down command will remove the set services, including the containers, the networks, and the volumes. So these two commands are only to be used when starting or ending the lifespan of set services. Now, by default, you can run these commands as they are, or you can specify a specific service. So you can say docker compose app, and that will start up both of these services, or you can essentially just say docker compose app and then a name of a specific service to start that specific service. The same applies for docker compose down. Now, with that knowledge in hand, let's go ahead and let's try to run our services. Now, the first thing you want to do is you want to actually go ahead and open up a command prompt at the location of your Docker Compose file. So this is because essentially Docker Compose will try to find this file at the location where your command prompt is running at. So basically, having that in mind, let's go ahead and let's try to run Docker Compose app at the location of our docker compose.yaml file. So let's go ahead and run the command and let's see what happens. So the first thing happening is that our Redis image is being pulled, and this will take some time. And basically, again, this is just downloading the Redis image from the Docker Hub repository. So as you can see, the image itself has been downloaded, and next up we are actually building our own image using our Docker file. So essentially we're executing all of these commands inside of our Docker file. So now, as you can see, everything is running. And if we actually pull up a Docker client, so this is a visual Docker client, you will be able to see that now we have two images. The first one is called part2 web, because the folder in which the Docker Compose file is located is called part2, and then our service is called web. And the second one is simply called Redis. And now, if we actually go into the container section here, you will be able to see that in here, we have a group of containers called part2. And if we click on the arrow here, you will be able to see our two containers running. So basically, we can actually see the same thing if we go into our command prompt. So let's go ahead and open up a new terminal. And this time we actually want to see the running containers using docker compose ps, which is another command that can be used to list the available services. So let's cd into our directory here, and now we can say docker compose with a ps at the end to see our running services. And as you can see, these are our services, and it tells us when they were created, it tells us the status, and it tells us the associated command. So basically, this is the information on our running services, and we can also do docker compose and then logs. And this will essentially show us the logs associated with our docker compose here. But as you can see right now, the docker compose command is attached to this terminal. So basically, if we hit Ctrl and C here, this will essentially stop these two containers. So effectively, we are stopping the two running containers by exiting the terminal. If you want to avoid that, you can actually go ahead and run the app command with the -d postfix, which will essentially run the Docker Compose in detached mode, just like you did when you started a container through a command line tool, as we explained in the previous video. So if I try to actually run my containers using the app command in detached mode, you will see that our containers are running again. So now, before we move on, let's actually try and let's visit our web application to ensure that everything works correctly. So to do that, let's open up our browser, and as you can see, the application is running on port 8000. So basically, all we need to do is visit localhost 8000, and as you can see, our application works, and every single time I refresh the page, the counter is incrementing, meaning that both our application and our cache works perfectly. So now, with our services running in detached mode, we can exit out of the second terminal, and let's try and run a few more commands in here. So let's go ahead and let's go back into our text file here, and essentially let's go and let's look at these commands in order. Now, just like with a container, you can actually use the execute command on a specific service to execute a command inside of that container. So actually, let's just copy that and let's go in here and let's just say web. And after that, let's go ahead and say bash and let's hit enter. Now, obviously in this case, it could not execute bash due to the image that we're using, but we can try and run sh instead. So let's go ahead and do that. And as you can see, we've successfully entered the terminal. Now we can just say ls, and as you can see, we can successfully see our Docker file, our application file, and our requirements file as well. And then we can just say exit, and this will exit out of the terminal. And next up, we can also use build, and this will rebuild the image inside of our service. So let's go ahead and let's try to run docker compose build and without specifying a container, and let's hit enter. And as you can see, this attempted to rebuild our image. So essentially, again, we can just say docker compose and then ps. And as you can see, it attempted to rebuild our image, but obviously since nothing changed in our Docker file, it simply used cache to essentially go through each layer. It did not find any changes. So basically the entire process finished in only 4.7 seconds. Now, on this note, I want to take a second to explain how caching in Docker works. Now, every instruction in here is considered as a layer, and each layer is cached by default after you build an image from a Docker file. So every single time an instruction is executed, if the instruction has some sort of output, the output will be cached. So for instance, downloading files or installing something through your run command produces an output, and that output will be cached. Now, the idea here is that every single layer in here is being cached, but as soon as you change a layer, the cache is invalidated. So if I go to this copy command here, and I change the name of the file from requirements to requirements1, like so, the cache that has been previously created will be invalidated, and this command will be executed once again. However, it doesn't stop there. You should be very careful because the cache of every single instruction from this point onward will be invalidated even if those instructions have not been changed. So in other words, even if you only change this instruction here, the cache of this instruction and all of those instructions will be invalidated as well. So in other words, you should always place the instructions that are not supposed to change at the top, and then you should place the instructions that should change at the bottom. Otherwise, if you change something at the top, from that point onwards, everything else will be invalidated, and your build time will increase significantly since you will need to wait for Docker to execute all of these instructions once again. Now, again, if we go back into our terminal, as you can see here, the build here only took 4.7 seconds, while the initial build here took 55 seconds. This is because everything in here has been cached, so basically all Docker did here is to look up the cache and validate that nothing changed. And this is why the application also remained the same, because Docker simply verified that nothing changed, and it essentially loaded everything from cache. So moving on, obviously you can use the build command on a specific service as well. So if I just say web, it will pretty much do the same thing. It will try to validate the cache and it will try to rebuild our web service. So let's go ahead and let's move on. And the next command is pull. I'm not going to be demonstrating this command, but you can use this command alongside with a specific image to essentially pull that image. So it works exactly like you would use Docker pull to pull a specific image. So with that said, let's move on. And next up, we have the start, stop, restart, pause, and unpause commands. Now, these are very straightforward, And unlike the up and down commands, you can use these to essentially start and stop specific services without actually deleting or creating containers, volumes, and networks. So basically, we can go in here and we can say docker compose, and then we can just say stop and web, and this will stop the web service. So now if we say docker compose and then ps, as you can see, the service has been stopped. So basically, we can now go back and we can actually say start instead of stop. So let's just say start, and this will effectively start the service again. We can also pause a service, so we can just say pause, and this will effectively pause the service. And then we can unpause the service, and obviously this will simply unpause the service. Besides that, we can also restart the service, and this will effectively again simply restart the service if necessary. And as you can see, the service has been restarted. And lastly, if you want to see the statuses of both running and stopped services, you can use Docker Compose PS with the postfix, and if you run that, you will be able to see the statuses of both of your services. So in this case, the web service is stopped while the Redis service is running. And again, you can see the same thing via the GUI. And as you can see here, this icon, which is the group icon, is yellow, signifying that not all of the services are running. And of course, you can also start the service again manually through the GUI by simply clicking on the start button, and it will similarly start the service. And with that said, we're pretty much done with everything you need to know to start working with Docker Compose. Now, in the next video, we're going to be covering even more advanced topics, but for now, that's about it, so make sure to post any questions or suggestions in the comments below, and also make sure to like and subscribe since it helps the channel immensely. And with that said, I'll see you in the next one.